Unit 16, Day 1, Factoring with GCF. Now, if you don't remember, GCF stands for Greatest Common Factor. Alright, now, if you don't remember what a factor is a piece to a multiplication problem. We multiply two factors together to get a product. Okay? Products are the answer to a multiplication problem. So, moving along here. That's the explanation of the title. So, number 1, it asks us to find the missing factors. Now, we all know that 2 times 3 is equivalent to 6. Now, y times y to the third is going to be y to the fourth, okay? If you don't remember, we're supposed to add exponents whenever we're multiplying things together. Now, number 2, 3 times 3 is going to be 9, so we put a 3 here. Now, let's see, a squared times a will be a to the third. And then we've got b squared times b squared will equal b to the fourth. Alright? Number 3. 7 times negative 5 will give me negative 35. And x squared times x to the 1 will give me x to the third. Okay? Don't forget, we add the exponents when we multiply stuff together. And then y to the fourth will be y to the fifth when we multiply it by y. Now, number 4. Number 4, we have 3 factors going into this. So we got 2, 6. 2 and 6 multiplied to give us 12. 12 times 3 will give us 36. M cubed times, well, there's nothing there, so we need to go 3, and we need to get 5, so that's going to be m squared. And then let's count up our n's. We've got 1 and 5, that's 6, so we need 1 more, so we go n. And there's the end of that problem. Very simple, okay? Don't complicate those problems for yourselves. Alright? Now, number 5. Okay? It asks us to find the greatest common factor of the given monomials, all right? Now, here's the thing, okay? Greatest common factor, there's a couple of ways to go about finding them, but the best thing that you can really do is to be able to see them and just look at something and be able to go, boom, I know what that is. So, if you'll notice, on number 5, we've got A and we've got W. No common factor between those two, but 17 and 34, 34 is divisible by 17, okay? 34 equals 17 times 2. All right, so we do 17 as our greatest common factor. Number 6, all right? Now, 11 is prime, all right? And nothing will go, and 11 will not go into 40. The closest thing is 44, but let's see. So there's nothing there really for us to work with. Now, what we're going to look for is the smallest exponent variable, basically. So a squared will be the greatest common factor for that. Now, number 7, okay? Something I want to go ahead and just point out. Lots of people like to make a factor table. We've got 1 and 15, 3 and 5. Alright, and then we can do the same thing for 35. We can go 35, and then that's going to be 1 and 35, 2, 3, 4, 5, and 7. And then that's it. So if we think about it, 5 is the biggest number that will go into both of those numbers, right? So the greatest common factor will have something to do with 5. Now, right here, b is the smallest exponent, and then k squared is the smallest exponent for the k's. And that is our answer right there. All right, number 8. Okay, so let's see. Common factor here would dictate, let's see, I'm seeing that 5 and 2, there's nothing that'll go into both of those evenly. But we can factor out, do what's called factor out in A. So what we're going to do is we're going to go ahead and we're going to divide this by A and divide this by A. This is where that whole thing from the last unit, the whole dividing stuff, comes in real handy, okay? So we're going to put what we're dividing by on the outside. Okay, 5a squared divided by a is going to be 5a. And then 2a divided by a is going to be minus 2. All right? So we put what we divided by right here. And then what comes out is right here. Okay? All right, number 9. So what we're looking to factor out is the smallest available variable exponent. So combo. So if you'll notice here we have an a, all right, and we have an a here, so that means that we could factor out an a. All right, and then we could also factor out a b. They both have a b, so we can pull out a b as well. So ab, we're going to divide each piece by ab. Now we put an ab on the outside, and then ab into ab squared is going to be b, and then a squared b is going to wind up with a, and that's it. All right, now number 10, if you'll notice, 2 will go into both 6 and 10 very easily, so we put a 2 in there. So 2 into 6 is 3, so we got 3x. And 2 into 10 is 5. And there we have it. It's that simple. All right? Now, number 11, okay? Number 11, things that go into 14 and 21, I'm going to go with 7. All right? So we can divide each of these by 7, but there's also a c in both of those, so we can take out a c as well. So we're going to put a 7c here, and then 7 goes into 14 2 times. C goes into c squared, or c cubed, c squared times. And then, let's see, the c's here cancel, and we're left with 3. And there's our answer. All right? Now, number 12. All right, things that we can pull out, okay? A 3. All right, now we're going to go with the smallest exponent for the p's. That's going to be a p. And then for the q's, that's just a 1. Q, right? Now, 3 goes into 6 twice. P goes into p squared p times. Q goes into q 1 time, so we don't write anything down for that. Now, 3 goes into 9 3 times. And we've already got the PQ. And there we have it. That problem is finished. All right. Now, let's see. Number 13. Okay. Number 13. We've got 2a squared b squared, 10ab. Now, things that can go into both 2 and 10. Well, 2, obviously. So, we're going to pull out a 2. And then, if we notice, we got a and b here. We got a and b here. So, we can pull out an a and a b. All right, now in order to get the 2a squared b squared, let's see, we'd have to multiply 2 times 1. A times a would give us a squared. B times b would be b squared. And let's see, and that part's done. So 2 times 5 would give me 10. A times 1, b times 1, and there we have it. So we have 2ab on the outside of ab plus 5. And there's the end of it. All right. Now number 14. We've got 7y squared minus 21y minus 14. All right. Let's see. Numbers that go into all three of those evenly, the only thing I can think of is 7. So we're going to go ahead and try 7 on the outside of, let's see, 7 times y squared would be 7y squared. And then 7 times negative 3y would give me negative 21y. And then 7 times negative 2 would give me negative 14. And there's another answer. All right, let's see. Number 15. Okay, we can pull out, let's see, a number that goes into all three of those. I'm going to go with 6. And if you notice, we don't have a common variable to pull out. So what we're going to do is we're just going to say 6 on the outside of 3x minus 2 y plus 6. And there it is. It's that simple. All right, now, whenever we have numbers like number 16, okay, what we need to do is go ahead and pull out a negative, okay? So we're going to pull out a negative, let's see, number that goes into both of these evenly, we're going to go with a negative 3. All right? And then, let's see, we got an x in both of those. The smallest variable is 1, or the smallest exponent for those x's is 1. So we pull out an x. And then, let's see, y squared. All right? Now, negative 3 goes into negative 15 5 times. X times x would give us x squared, and then y squared times 1 would give us y squared. Minus, let's see, negative 3 times 2 would give us negative 6. Oop, no it wouldn't. Plus 2. Negative 3 times 2 would give us negative 6. And then x times 1 and y squared times 1 would give us the rest of it. So what we wind up with is negative 3xy squared on the outside of 5x plus 2. All right, and there it is. All right, so second page now. At this point, the factoring should almost be practiced like in nature. Y'all should be getting pretty good at this. Now, on number 17, if you'll notice, there's nothing that goes into both 17, 24, and 1 evenly. So what we're going to do is we're going to look at the variables first. Okay? Smallest thing that we can pull out is the x squared with this. Okay? Now, we've got a negative leading coefficient. Okay? We don't want that negative sign. So what we're going to do is we're going to slap a negative on the front of this. Okay? All right, now that's going to leave us with 17x squared plus 24x minus 1. And there we have it. All right. Finished. All right, now Number 18. Number 18 talks about, let's see, we've got 14, 21, 7, and 56. All right, now notice we don't have a P on all of those. All right, so that means that we're not going to be pulling a P out of this. All right, now, things that I noticed, though, is that we have a 7. 7 goes into 21, 14, and 56. So we go 7 into, that's going to be 2p cubed minus 3p squared plus p plus 8. And there we have it. All right? 7 times 2 is 14. 7 times negative 3 is 21. 7 times p is 7p. 7 times 8 is 56. And there we have it. All right? Not that difficult. So, number 19. A civil engineer needs the area of a rectangular lot to be 6x squared plus 5x feet squared. Factor this polynomial to find expressions for the dimensions of the lot. So, let's see, what can we do? All right, let's go ahead and write it down. We got 6x squared plus 5x. All right, now, there's nothing that will go into both 6 and 5 evenly. But, if you notice, we've got an x term and an x term, so we could pull out an x, right? So we can divide each of these by x. All right, we're going to put an x on the outside, and we're going to fill in the inside of this. All right, x goes into 6x squared 6x times. X goes into 5x 5 times. So, we've got x, and we've got 6x plus 5. No big deal. Now, it says to find the length and the width if x equals 10. So, if the length, if x is 10, we're going to put it there, we're going to put it there. That means that the length would now be 10. And then, let's see, we're going to go 6 times 10 plus 5, that's equal to 60 plus 5, which is equivalent to 65. So our width would be 65. And there it is. Problem finished. All right. Now, number 20. The area of a rectangle is 21c squared plus 4c. Find the length and the width if c equals 4. What are the actual dimensions of the area of the rectangle? Now, we have 21c squared plus 14c. All right, now, first thing that I notice is 21 and 14 are both divisible by 7. All right, now, I notice that I have a c on both of these, so I can take out a c. Okay, so I'm going to go 7c on the outside of, and we're going to divide 21 by 7, that's 3. C squared divided by c is going to be c. And then, let's see, 14 divided by 7 is 2, and then the c's cancel, so we're left with 3c plus 2. So our length is 7c, our width is 3c plus 2. Alright, now, it says that c equals 4. Okay, it's wondering about the actual dimensions, so we take that 4, we're going to put it there, and then we're going to take it and put it there. So 7 times 4 is 28. And then 3 times 4 plus 2 is equal to 12 plus 2, which is equal to 14. And there it is. Finished. All right. And last little bit here, we need to figure out what the actual area is. So we got 28 times 14, which is going to equal 3 92. And there it is. Done. All right.